All right, the whole functional part is going to reappear. It's very tightly connected to the router function model in our reactive story. But so if there's any questions around functional, we can take them right now, or we're going to see some more functional stuff in just a bit. But if there are any immediate ones.
We were talking about like zero reflection. Were you
Yeah.
guys looking into more of a like compile time dependency integration or this sort of stuff?
Like in Dagger?
Scala projects and Lightbend.
Not
you guys
in the
just explored it.
Yeah. We observe what's happening, right? I mean, Dagger, that's kind of nice. What we're doing here, in the functional registration model is not exactly compile time dependencies in the same ways, but I would argue it delivers very similar benefits, right? It's extremely efficient setup. In that arrangement, you wouldn't do any component scanning. There's literally no annotation processor active. So it does exactly what it says, right? Everything's in the code. It's using straight method dispatches everywhere. So to some degree, it's kind of our answer to the what about more efficient bootstrap setups. We actually have more than this. And now in Spring Framework 5, we also ship an index model for component scanning. We're generally trying to optimize startup times. But the outcome here is actually really, really nice, right? It's very, very straightforward and also very memory friendly. So in that sense, I don't really see us going more into Dagger territory. I really appreciate Dagger for what it does. And in an Android environment, things are a little different, of course. But for a Java server deployment arrangement, I would argue that what we're doing here is a perfectly fine balance in practice. But we don't intend to go beyond this, right? We make certain picks where we think it's worth investing into, and we're really happy with the arrangement here. I hope that's enough of an opinionated answer.
I will kind of refer to the question. What's your thoughts regarding Scala?
Yeah. It's well. How much time do you have? That could be a rather lengthy answer. I'm trying to keep it brief. We had a Spring Scala project. We actually still have it, but we don't actively maintain it. So we used to invest into a Spring Scala research project where we were trying to come up with, there was a Scala functional application context, and there were a couple of things that are sort of, that have a similar smell as what we're doing here with Kotlin. We were just never totally happy with the outcome. So both stylistically and in terms of the attractiveness towards a Java audience, we were never really happy on our end. Happiness on our end is not the only goal, right? So the other part is we never really managed to attract a Scala-oriented audience either. In Scala land, there are Scala ways of doing things. There are really nice Scala-oriented frameworks. I mean, Akka and Play are really nice at what they're doing. And we've been told that basically, I'm not really going to use this, right? So it was, on our end, an initiative without an audience, without much of an audience. And with anything we're doing, we're always looking for an audience. I mean, it sounds a little simple, but I mean, if you think about it, there are actually quite a few R&D projects out there that are not audience-oriented at all. So whatever we do always needs to be kind of ready for even larger scale audiences. And in Scala land, I mean, Scala is fine in its corner of the world. I just don't see it getting closer. So even with recent efforts on Lightbends and Legum, as a microservices framework, they seem to work more of our stack kind of vision, right? Not integrating with anybody else's stack much at all. And we are a very integrative solution. We're always trying to embrace wider Java ecosystem trends, and Groovy and Kotlin are just much closer to that mindset, much easier to integrate with existing libraries. mean, even if you talk about basic integration with collection types and all that stuff, Groovy and Kotlin are just so natural, and in Scala you always have a bit of a parallel world in terms of what the API is actually using and consuming there. So that's why, right? So we did actually quite significant. We spent significant time on this. We even had several milestone releases of the thing. But in the end, a couple of years ago, we decided not to continue our investment into it. As a community effort, anything may happen. But if there's not much of an audience, there's not much of a community, so not much is actually happening, in all fairness. And for other languages, the same reasoning would apply. Is the language attractive enough to people with a Java language background? Is it straightforward enough to integrate with Java-based APIs, frameworks, and libraries? That's the main characteristics that we look for. And Groovy and Kotlin really shine, both really shine on that front. I have yet to see any other JVM language that comes close here. So even Ceylon, Clojure is of course quite different anyway, but even Ceylon is sort of not really trying to be friendly to Java libraries, but then not really. We need languages, JVM languages, where they're really committed to a strong Java integration story. Commitment in the language design and commitment in the people. We need teams to work with. Open source is about collaboration with other open source teams. And we sound simple again, but we want to work with people who want to work with us, if you know what I'm saying. We want to work with people who really want to support us in our initiative, where there's a common goal that we're working towards and not kind of just a tolerance of somebody else's effort. Anyway.
So you see that the Kotlin is used all over the world?
Kotlin, at least given the short 1.0 final plus life that it has managed to attract a significant audience in a very short time. So if you extrapolate that trend, it really has some potential. There are no guarantees, of course, right? But Kotlin, they really mean it. I mean, my main concern about Kotlin was, is this really a serious effort on JetBrains' side? Do they just do it because they can, or do they do it because they want to make a difference? And initially, I wasn't convinced, but as of last year, they really started heavily investing into it in every single respect. They are now doing a Kotlin conf in San Francisco in November. Right? They're even setting up a conference ecosystem around it. Mm. They really mean it. They're basically committed to exploring the potential of that language. Right? In the end, it may still remain a niche. We never know. But it at least has the potential to be to become a sort of Groovy companion, right? Groovy is basically what we see as the ideal reference, right? We don't see a JVM language as competing with the Java language, right? We don't see it as, it's the next kind of Java, like Java is old school and this is the new thing. Not like that at all. It's sort of Java's the mainstream language. Where's the 10% potential, right? And Groovy definitely has that already for a number of years, and Kotlin at least has a potential to get there. I admit that from our perspective, there's always a little bit of personal opinion involved, right? So do we have a few people who really love the language? That's an important characteristic. We actually have a couple of people who are really into Kotlin. We need that, right? There needs to be somebody who really lives and breathes that thing. Otherwise, we're not going to do as good a job as we possibly could.
Does anybody use Kotlin in this project?
That's a good question. Is anybody interested in using Kotlin?
Right.
Yeah, that's what we're actually looking for towards it. I mean, if you'd like to play with it, now's a great time. Take Spring Framework 5.0 in 5 and see what you can do with it. It's as good as it gets from the Kotlin support. There's very little that we do for RC1 still. All right. So the reactive topic. this is easily worth an entire evening, right, on its own. So I'm going to do a bit of a motivation in combination with an introduction to our source code style here. But the topic is very deep. So let's start with why are we even bothering, right? Why do we care? In Springland, if it's about web applications, we were traditionally very servlet focused. From our inception, right? We started back in 2003, where servlet containers were only really starting to become as popular as they are now, the early days of Tomcat. This is, of course, still very much the case. The typical Spring-based web application on the server side is servlet container-based. We had portlet support for quite a while. If anybody cares, it's gone in 5. It's still in for the 3, so if you want to keep using it, stay on for 3x, right? But we always had, actually, portlet support was introduced very early. So we always had this parallel servlet portlet stack, but obviously the servlet stack was what everybody was using, and there was a bit of a very specific part of the market only but an interesting and sort of important part of the market that we did the portlet support for. But the days of portlets are gone from my perspective. And I would argue, although that's a little more debatable, that the days of JSF, Tapestry and Wicked are probably gone as well, at least from a strategic perspective. But that's a little more debatable. Portlet is definitely gone.
Do you think the server-side rendering is gone also, like that?
Server-side rendering, at least to the degree as it is being modeled in like Wicked or JSF, that's probably not. I mean, looking at where Angular and React are going, I have a hard time arguing that this is going to continue. There's a lot of existing stuff out there, of course, and those apps may still run in 10 years, be maintained in 10 years. That's okay, right? We still ship our basic JSF integration. I'm not saying we're abandoning this. We are abandoning portlets primarily because that thing isn't really evolving. And it's such a niche in the market where I don't see a commitment from any vendor except for Liferay anymore. And I don't know, right? It reached the end of its investment life on our end. And we are introducing a new web stack, the Reactive web stack in 5. We only really want to maintain 2 web stacks, right? Servlet and Portlet was okay for 10 years. Now Portlet's gone and Reactive is the second web stack that we're investing into, where we see much, much, much more potential than in ongoing support for portlets. Servlet containers, of course, are a specific abstraction in terms of interacting with an HTTP networking stack. We have to remind ourselves that servlets are a specific abstractions with very specific characteristics and to some degree unnatural assumptions baked into the model. They work when unnatural in the sense of not actually matching how the network stacks underneath the covers works, right? But sort of really easy to program against. In that sense, it's a good abstraction. But it is an abstraction that we've kind of grown up with. I mean, I'm talking about myself, right? I started Java web development with the Java Servlet SDK, the thing that preceded Tomcat back in 2000, or even was it, 2000-ish, in the year 2000. So I started thinking along the lines of the servlet model. And I would argue an entire generation of Java enterprise developers started to think along the servlet model. The only way we can imagine coding Java-based web applications, I'm simplifying, of course, right? But in general, the only way that we are considering is the servlet model with its thread per request assumption, there's a thread pool behind an HTTP socket. Every time a request comes in, we grab a thread from that pool, we own that thread, and we're going to process the request, and we're going to spend all the time that it takes to build a response, and until we've written the last byte of the response, we hold on to that thread, and only then we let it go back to the pool. That's basically the servlet model. A CGI-like, if anybody remembers, a CGI-like abstraction where basically an entire process is associated to a particular incoming request. That works well for highly efficient processing arrangements where you don't spend actually much time. Small request payloads, small response payloads, efficient ways of loading data for that response with aggressive optimizations, aggressive use of HTTP caching, aggressive use of application internal caching, very efficient data store access. If all of those things come together nicely, building a highly efficient web stack on a servlet container actually works great, right? There's nothing to complain about. If all of those assumptions actually hold. There are scenarios where servlet stacks have very suboptimal characteristics, in particular under high load. The problem with server containers is largely that it's too easy for the stack to become completely blocked. If the thread pool is exhausted, if all requests are waiting on some external system to respond, and basically all the threads in your Tomcat thread pool are all waiting on something else to happen, then there is literally no thread left to process this extra fresh little HTTP request that comes in. It would be trivial to process that request maybe, but there's simply no thread available to accept it. So the server has to reject it. That's why Java-based web servers tend to reject requests at some point. The infamous messages along the lines of server is busy, too many requests, try again later. Happens quite often these days, and it's often actually Java-based servers that you're getting those messages from. So predictable behavior in extreme scenarios, in high-load scenarios, or in unusual scenarios, in high-load scenarios, in scenarios where an external system is not reacting as it should, is an issue. And there are ways of getting around it. Of course, I mean, everything's, there's a solution for everything, right? By detecting the inavailability of certain systems, building circuit breakers into your system, there are ways of addressing this. There always are. But at some point you end up wondering whether you would have to re-architect your processing arrangement towards a model that is actually closer to the way that socket programming works, where you're not actually blocking a thread to wait on an external system to respond. Instead, you would come up with a processing pipeline, and whenever that processing pipeline says, I'm ready to process the next step, that's when you're calling it back. If you're currently waiting on something, you just basically park that pipeline somewhere, in a runtime processing stack. It's going to occupy some memory, but it's not going to occupy a thread or block a thread. Anyway, we're going to revisit this I'm going to revisit that line of argument in just a moment. These ideas aren't new. I mean, in the end, they are like everything in IT. They are actually really old. But even in our recent times, in our lifetime, basically in our work lifetime, they are not actually new. There are quite a few stakeholders in the so-called reactive space, right? The reactive manifesto is already a sort of agreement, a common statement by several stakeholders. I'm not a fan of manifestos, really, but the qualities or the characteristics highlighted by the Reactive Manifesto are quite all right. In particular, responsiveness and resiliency are certainly characteristics that we aim for. So from a Spring Framework perspective again, why are we doing a reactive web stack? It's in particular to have a different way of building responsive and resilient web architectures. Instead of trying to tune a servlet stack and kind of do the best we can within the servlet model, we are taking a more radical perspective and saying, like, what if we actually built a reactive HTTP processing architecture where characteristics like responsiveness for newly incoming trivial requests or resiliency against unknown state of third-party systems is kind of a natural part of the story and not something that you have to kind of defend yourself against, right? Where there's a more natural way of handling such scenarios. Beyond the manifesto, which is essentially just a bunch, a couple of sentences and a diagram, there is actually a collaboration initiative called Reactive Streams. This is the part that really got me personally excited about this or interested in this. It's literally reactivestreams.org. A bunch of interfaces living in the org.reactivestreams namespace. It's a collaboration between a couple of people at Lightbend, the RX Java team, the Project Reactor group in the Spring ecosystem at Pivotal, and a few others, where we're trying, or where this actually has happened a while ago, right? Where the goal was to model a typical back pressure driven stream interaction. This is pretty low level, right? So it's essentially a step taken towards establishing a sort of ecosystem in the reactive architecture space, where through modeling a core concern of reactive streams processing, we enable a whole ecosystem of HTTP servers, of data store drivers, of web frameworks, being built on the same reactive streams abstraction to interact with each other underneath the covers. And reactive streams is actually super trivial. I mean, in the end, what it models is a very straightforward arrangement. In the central element are publishers in reactive streams. They are basically processing pipelines being able to deliver data. But instead of those just pumping the data towards some output channel, they don't actually do anything until a subscriber registers. So the publisher is basically just a set of instructions of a data processing pipeline, right? And the moment the subscriber registers, the subscriber may start asking the publisher to send a few chunks of data towards it as the subscriber is capable of actually processing them, and only once the subscriber is actually registered. So this interaction model, the whole notion of back pressure comes in through the subscriber being in charge of flow control. So things are only happening when the subscriber says that they should be happening. So if the subscriber is an HTTP output channel back to a client, if there's currently network congestion or anything else preventing us from sending further data back to that client, then the subscriber basically just says like, thanks, publisher, don't give me any further data. Only when the network buffers allow for processing further data, the publisher is asked to deliver further data. The publisher may, for example, be a processing pipeline coming out of a Mongo database, right, for certain documents to be streamed to the client, whatever. So this is what reactive streams are modeling. Reactive streams is a key enabler in the puzzle, but it's not actually what you're coding against. This is what libraries and frameworks are based on. So if you are reading about, for example, RX Java 2 or our Project Reactor 3 or in our Spring reactive efforts, they are all based on reactive streams. Recent data store drivers are also based on reactive streams. Actually, the early reactive data store drivers for Couchbase and for others are RX Java 1 based and don't actually model reactive streams and back pressure underneath the covers, but they still do a reasonable job in asynchronous access to the data stores, but they are not fully integrated with this model quite yet. So we, from a Spring Framework perspective, of course, had the benefit of this initiative already having delivered when we started. So we literally started when Reactive Streams went final. And in close collaboration with our Reactor project, our kind of sister project, Reactor 3 and Spring Framework 5 are very closely related. We came up with the idea of investing not only into a web framework, but also into a reactive kernel, which is Project Reactor, and a composition library, which also comes with Project Reactor. In the end, Reactor is a sort of alternative to RxJava. So if you've has anybody been working with RxJava or read an RxJava tutorial maybe? A lot of the knowledge that you got out of this, right? A lot of your understanding of what RxJava does and how to use it very naturally translates onto what we're talking about here. So Project Reactor literally is a sort of tightened up, smaller, more focused version of RxJava. Java 8 baseline, reactive streams based, and with only 2 reactive composition types instead of like 7 or whatever RxJava 2 has in the meantime. So RxJava is great, and we actually support it as well if you choose to use it. But our Spring Framework 5 reactive stack is internally based on Reactor, and we always adapt from the types that you're using to Reactor internally. So what does the stack actually look like? There's quite a bit of a potential misunderstanding here. In Spring Framework 5, we actually have 2 web stacks. We already explored that. No portal stack anymore. There's a servlet API stack. The servlet API stack is largely the same way that you know it, right? It still exists in Spring Framework 5. It's actively evolved. It's servlet 4. It's early servlet 4 compatible. It has a few refinements, but it largely is the same stack that you have been using for the past decade, right? In Spring Framework, the Spring Web MVC framework on top is not only servlet API based, it actually embraces the servlet API. You can declare HTTP servlet request and response arguments, HTTP session arguments, or push builder now in servlet 4. In your Spring MVC handler methods, you may choose to interact with the servlet API very directly. We are not trying to hide the servlet API, we let it shine through intentionally. Everything is servlet based. The SPI contracts, the integration with template libraries, everything is servlet API based. This opens a whole ecosystem of third-party libraries out there. We have tiles integration, ThymeDiv integration, of course, FreeMarker, all that stuff based on the servlet contract. This remains in place, including all the third-party libraries out there that work with Spring Servlet MVC. And the common way of consuming this, of programming on top of this, is, of course, the annotation-based controller model with its request mapping or methods. The traditional Servlet MVC-based controllers. Even if you're not using the Servlet API in your controllers, you can, but you don't have to, right? Even if you don't import any Servlet API artifacts in your controller classes, you actually designed those controllers to run on a servlet-based stack with servlet-based invocation semantics. Your handler methods are actually invoked within a servlet processing thread, owning the request, right, and supposed to produce a response and then return. That's the job of a Spring MVC handler method, of a request mapping method. So that's pretty much the way you know it, right? In parallel to that, in Spring Framework 5, we introduce a completely fresh web stack, which of course has its connection points. You know, it shares a little bit of code and it shares a lot of design and some common programming patterns with the WebMVC stack, but it essentially is a separate web framework that we call Spring WebFlux. It literally lives in the Spring WebFlux module. Like you basically choose to use Spring WebMVC or Spring WebFlux. The reactive stack underneath is Reactor-based, Project Reactor-based, reactive streams-based. It's an HTTP stack based on, well, a choice of HTTP servers underneath the covers. And using a Reactor HTTP layer on top with reactive streams processing. So even if you see names like Tomcat and Jetty appearing down here, don't let that irritate you. Tomcat can be used as a servlet container. Jetty can be used as a servlet container. But what we mean here is that we are using the Tomcat and Jetty HTTP kernel as a reactive web server. Basically, the servlet API, if it appears at all here, is just an implementation detail for a few details down here. This is not Tomcat in its usual incarnation. It is Tomcat core as a reactive HTTP engine. So we actually have direct support for Tomcat, direct support for Jetty, like native support for Tomcat and Jetty, and native support for Undertow core. In Undertow, that's a little more obvious since Undertow actually has two distributions, an Undertow core and an Undertow servlet distribution. We are not even using Undertow servlet here. We are talking straight to the Undertow core HTTP server. But the reference probably is Netty, right? Everybody out there building a reactively enabled web framework right now, a web stack right now, seems to use Netty. Like if you look at everyone from well, even Play, Redpack, Vertex in particular, right? They are all Netty based. Netty is a really rich, extremely capable, very sophisticated networking library. It's probably the most extensive and most capable and most highly tuned networking stack that we have in the entire Java ecosystem. Everybody seems to agree on that. Nobody tries to compete with it at that level. Literally, Netty doesn't have immediate competition for what it's trying to accomplish. And of course, for us, it's a reference model as well. The most efficient, most customizable web stack that you could possibly build with our WebFlux framework is on top of Netty. At the same time, using it on top of Tomcat is a perfectly fine decision. Tomcat is actually a really fine HTTP engine. And there was some active investment into Tomcat to make it more suitable for a reactive web stack. So of course, Tomcat, we have three full-time Tomcat committers at Pivotal, so very close to us, to the Spring team. So this is no coincidence. We even extended the team. We hired Violetta out of the Tomcat community, and she spends most of her time improving Tomcat's reactive story. So she's a committer both on Tomcat and on the Spring 5 web efforts, trying to improve the role of Tomcat there. And this works really, really well. So in the end, we have a choice of those 4 HTTP engines that we have first-class support for. There's actually potential for others to be added to that list behind a reactive HTTP abstraction. But those are the 4 that come out of the box. There's our reactive HTTP layer on top, living in the Spring Web module. And there's the WebFlux framework as the typical way of consuming this stack in parallel to the servlet stack. Now, what's the business up here? We have an annotated controller model for the WebFlux framework, which syntactically looks like a Spring MVC controller, but it really is a reactive web controller. We're going to see that in just a moment. But it's using some stylistic similarity, which actually works out really nicely. As an alternative, there's also a completely different way, syntactically, of using the reactive stack, which are router functions. And both of them are actually best explained by example. So this little thing here looks like a Spring MVC controller initially, doesn't it? I mean, it literally uses the same controller annotation, the same structural arrangement. It's a component class. The component class does typical component things like the dependency injection, the component state. It even has request mapping methods. I mean, in this case, 2 get mapping methods, as Spring MVC in 4.3 would have. If you look a little bit closer, you see that those are not regular Spring MVC controllers. Because in a Spring MVC arrangement, the job of every such handler method is to take the request and process it or return a view for it, right? But in the end, to process it. The purpose of these handler methods seems to be different because they return these strange things here. A mono and a flux, those are 2 incarnations of Reactive Streams publishers. So their job is different. These controllers, such controllers, are actually designed to run on the WebFlux framework on a reactive web stack. For every incoming request, the WebFlux framework is going to dispatch through its mapping predicates to the particular handler method. So if the request /users comes in, we're going to dispatch to this getUsers method. And we're calling the getUsers method to return a processing pipeline for the given request to us. So the job of each such handler method is to build a processing pipeline for the given request, but not actually to process the request, just to give us basically instructions for how to process the request. What we're seeing here is what we're working towards as the common scenario. Those controllers should actually be very thin, very light. Ideally, you would have a repository layer or other delegates underneath that are also reactively designed. So a repository saying like, I want to find all users, a user repository finding all users, but not actually loading the users on the find all invocation, but rather returning a reactive streams publisher, which is capable of loading all users once a subscriber tells it to do so. The reactive data store drivers out there for like Mongo, for Couchbase, there are even initiatives for Postgres. They are all capable of working like this. So in an ideal world, and we actually have Spring Data K as a project doing this, we want reactive repositories to delegate to. Wouldn't it be nice if it was always so straightforward? But even if you had to do something different here, reach out to another microservice through a reactive web client and kind of come up with the reactive streams publisher for the outcome of that call to that other service, it all ends up with a reactive streams publisher that you're returning back to the framework. Now, what is Mono and what is Flux? That's where Reactor comes in. With Project Reactor, we have two first-class reactive types, Flux and Mono. Basically, out of the box, very rich reactive streams publishers, along the lines of what RxJava has with observable and single. So in the end, you can think observable here and think single or completable here in RxJava terminology. Or in RxJava 2, you could think flowable here. That's actually even closer. Semantically, a Flux is a stream of objects, right? So like in RxJava with an observable, it's kind of a hot stream. Like flowable in RxJava 2, it's actually a back pressure enabled stream. But it is a whole sequence of objects that we're going to build when we're actually registering a subscriber for it. Mono semantically is a single object or none. So you could argue, or maybe as a kind of mental hook, you could think Java util optional here. Mono is a sort of reactive version of Java util optional, and Flux is a sort of reactive version of a Java util stream. Sort of. Right? Like any comparison, doesn't really work in the details, but semantically it's quite all right here. So in this reactive stack, this is basically modeling two endpoints. We can actually see that like the extraction of path variables or the access to request headers, to query parameters, to cookies, all of this uses the same syntactic elements that you also use in Spring MVC. There is a strong similarity here. I mean, this is not just another annotation named path variable, it's actually the same annotation as in the Spring MVC model. We are reusing those annotations. Those annotations live in Spring, in the common Spring web module for a reason. So this is the annotation-based model. And of course, this can be taken to any level, any number of controllers, any number of handler methods, any complexity of handler method signatures. Just remember, the job of those handler methods is to build a processing pipeline. Maybe before we move on to the functional model, and since we have the time, a bit of an illustration for what actually happens at runtime here. These kinds of controllers run with an event loop. So in a reactive web stack, there is no request processing thread pool. There is just an event loop with a thread scheduler and usually a number of requests roughly matching the number of cores available in the system, but not significantly beyond that. This event loop is basically the central hook with the networking stack. So every time something's happening, an event is happening, in the network stack, this event makes it into the event loop, and we dispatch out to a handler for that particular event. So for an HTTP request coming in, a new HTTP request coming in, basically this event loop is where the dispatch is coming from. The event loop says like, yeah, I have a mapping predicate matching this particular HTTP request. Now I'm dispatching to this get user or this get users method here to give me the processing pipeline. We are being called within the event loop. So whatever you do here shouldn't be costly, shouldn't block, by no means do a blocking operation here. This is equivalent to building a user interface and trying to do something extensive in the main rendering event. Yeah? Everything freezes if you're doing this, right? This is sort of related to user interface programming to some degree. It's certainly a commonality, the event loop-based dispatching. So you're only supposed to build a processing pipeline, a bunch of objects basically, very efficiently without actually reaching out to any external system or doing any other blocking operation. And then you return that pipeline. Now it's back in the reactive kernel managing that event loop. That pipeline is now being triggered as data comes in, as the request flows in, as the body of the request flows in. The event loop is going to call to dispatch basically back into the individual processing steps against the scheduler that it uses at runtime. So the runtime representation of this processing architecture is actually very close to how operating systems, network stacks, and even the hardware itself works. Right? We're not trying to use the thread abstraction in Java much at all. We're trying to adapt as closely as possible to the actual concurrent processing capabilities of the underlying, hardware in the end. Because, of course, in the servlet model, you may have a servlet thread pool with 150 threads, but how many threads are you actually going to process in parallel? Limited by the number of cores, right? By the hardware capabilities. Here we're trying to be very close to maximizing the cache locality for each associated thread. There's a whole world of thinking behind why you would want to do this. But it's kind of interesting that from a user programming perspective, you can largely ignore the underlying stack as long as you remember that what you're building here is a processing pipeline. You're not supposed to do blocking operations within the handler methods. You're basically adapting to the capabilities of your runtime stack through a reactive processing pipeline. That sounds easier than it is. I openly admit that programming in this kind of world has its implications. So this is not necessarily a trivial exercise. And showing the functional model exposes you to a little bit more of what it really takes to live and breathe that model. So this is the same endpoints that we're modeling here in the annotation-based world, but with a functional callback model. This is what we call router functions. Actually has two essential components called router functions and handler functions. In a router function essentially says, for certain incoming requests, I have a couple of mapping predicates, and for every matching predicate, I have a handler function that I dispatch to. This is sort of equivalent to the handler method thing that we had before in the controllers with their mapping annotations. It's just that the mapping predicate is programmatically composed, and the handler function that we're dispatching to for processing it is literally a handler function interface, a functional interface, which in Java 8 can refer to an inline lambda expression, or in this case, to a method reference, to a Java 8 method reference. This little example here only works with a couple of static imports. So in case you're wondering, where does the route method come from? It comes from router functions. It comes from router functions. So there's a router functions and the request predicates static import here, where we get the route methods and the mapping predicates from. But those, would just disappear somewhere in the input block. This is the code that you actually would read. So for any incoming requests that matches, we dispatch to a handler function. Handler function has a signature of request comes in, and essentially instructions for a response are going out. We are not doing reflective dispatching to annotated methods here. No flexible signatures, right? we're in the functional world. In the functional world, there's a target interface. The target interface has a particular signature, and you have to programmatically code against that signature. No add path variable annotations for extracting path variables. Instead, there's this request argument, there's a request API type coming in. If you want a path variable parsed out of that request, you need to tell the request to give you a path variable programmatically, right? So what's up with, let's start with the getUsers method. What's up with the method body? We need to produce a response, complete instructions for arriving at an HTTP response for the given request. So let's assume we still have this repository that we can so conveniently delegate to. We call find all. We get a Reactive Streams publisher for a user stream, a flux of users out of it. Now, this is the body, right, of our response. In order to actually produce the response, we need to now say like server response, builder. The builder start with the HTTP status. So OK is basically status, HTTP status OK. We pass in the publisher for the body. And we, for conversion purposes, because we're not going to send user objects, we're not going to serialize user objects. In this case, this has a Jackson converter registered, where we are partially rendering JSON objects out to the response in order to give it a hint about this conversion. In Java 8, where we have no runtime retention of generics, we have to specify user as a hint for the to be converted type. We can largely ignore this, right? Basically, we're passing in the body publisher here and returning this. So this builder API that we're triggering here actually builds a mono of server response, a Reactive Streams publisher for the response, which contains a Reactive Streams publisher for the body. But all of this is essentially a chain of publishers. So even the response headers are expressed through a Reactive Streams publisher that is only actually invoked and setting and producing those headers when the response is ready to be written. So, I mean, that's the straightforward case. Just to illustrate a little bit more of a programmatic exercise up here, this is not the only way of coding this, and it's a bit naive the way it's coded here, but it does the job, the same job as the method before. So, if we want to produce a publisher for a specific user, we extract the path variable, ID. We start building a Reactive Streams publisher chain, like a mono is a composition type. So like an RxJava single or an RxJava observable in the general case, or even like a completable future in standard Java terminology, there are composition methods, like do this, then that, take the outcome of this, pass it into that, building a whole pipeline. So in RxJava land, if you've seen that before, it should seem familiar. So starting that pipeline with like a just method says basically, let's start with this value that I have already, like the extracted path variable. Let's pass it through a transformation step where we're converting it to a long, assuming that the findById method has a long argument, needs a long ID. So pass it through a long transformation and then pass it into the findById method, and we're referring to it as a Java 8 method reference again. This essentially says like, take the path variable, if you're already converted, then pass it, then call findById with the given argument. And well, that's the body publisher, right? This is just a sequence of transformations basically and invocations that we now have as an object, this mono of user. We're passing it into the body of our response publisher. And that's what we're returning. This is very close to what's actually happening at runtime. This is literally, there's basically no abstraction in between, right? This is the way that the networking stack works, and this is the way that you're coding. So in that sense, it's closer to the metal to some degree. And hopefully at the same time reasonably convenient in what it does. Now, at this model, of course, we chose to have callback methods on a delegate class, and that's generally very recommendable. There's a couple of interesting qualities coming out of this. Now, this code is now on the same page, but it doesn't have to be. A router function can be somewhere in the startup class, like in a Spring Boot 2.0 application class. There could be a router function being in the literal application class, like at the very start of the boot application. Taking a handler delegate as an argument and referring through method references to that handler delegate. There may be any number of delegate methods and any number of delegate classes. Nowhere does it say that there's only a single delegate, right? There could be 10 routes, dispatching to 3 different handler delegates, each with a few methods. Even if you have 10 routes, that's like 10 lines here, right? So that would even scale to, well, could even fill a page with 20, 25 routes very easily and dispatch out to the separate delegate methods. The idea here is that the mapping information is completely independent from the actual handler methods. It doesn't have to live as an annotation on the particular handler method. So you can have a kind of routing DSL at a central point of your service setup. Think about microservices architectures in particular, where there's maybe just 5, 6 endpoints for a particular service. And there's a really nice overview if you have them in a compact form next to each other at a central point of your setup. Right, so there's a strong decoupling between the routing part and the handling part of a request, all in a programmatic fashion. The predicates themselves are a programmatic model. You can implement your own predicates if you want to, or reuse the ones that come with request predicates with the static import that we provide here for the common HTTP cases. Right, and another benefit of this arrangement is it very naturally works with any kind of Java 8 language arrangement. So this is in combination with method references. You could do the very same with inline lambdas. So what if you took the same 2 endpoints, but instead of choosing to factor out handler methods, delegate methods, we just embed the same code in a lambda expression, right? Because in the end, this routing DSL just needs a handler function. And in the Java 8 language model, implementing the lambda function as an inline lambda, request coming in, response going out, is actually quite nice. There's even the signature disappears, right? With the lambda function in general, you never see the signature of the callback interface. So we don't even see the server request coming in and the server response going out signature at all. Of course, try to scale this, right? I mean, you're not going to scale it very far, but say for the 5 or 6 endpoints that a particular microservice may have, this may, and for very straightforward dispatching to a repository layer where you're only really adding a few HTTP specifics, this may be actually quite nice and even fit on a single screen for an entire microservice. So it's an extremely flexible, highly decomposed, and totally reactive from the ground up model. Obviously, you're only going to use this if the stuff that you need to do can be expressed in a reactive fashion. And the most natural boundary is the data store. So for the purposes of these examples here, I always assume that there's a repository capable of doing it. Of course, you can only implement such a repository if you have a reactive data store driver. That's where our Spring Data project comes in, but we can only do our part if the particular data store offers a driver, a driver with the fundamental capability, or at least asynchronous interaction, ideally backpressure-driven interaction. This is true for a number of data stores, but not for traditional enterprise databases. So if you're talking to a traditional SQL database, an Oracle or a DB2 instance, basically, you're going to find out about it pretty quickly that the only way to interact with those drivers is with blocking API calls. In this kind of model, there's no natural way to include blocking API calls. If you want to do this, you need to use patterns like a worker thread pool, where blocking calls are factored off to a worker thread pool, and the outcome of an asynchronous call to that worker thread pool, the future that you get out of this, that's the sort of thing you can build into your processing pipeline again, right? There's always a way out. But simply speaking, this model is to be used in combination with reactive data store drivers and reactive client libraries in general. Then and only then you're going to get the maximum benefit out of this. This unfortunately includes any kind of thread-bound transactions, in case you're wondering about those. So thread-bound transactions, generally resource transactions, are generally closely aligned with blocking data store operations. Reactive data store drivers in general don't have thread-bound transactions or even resource-bound transactions in the traditional sense at all. There are ways of mimicking or identifying a certain sequence of operations. I mean, we're now in data store business, right? But not the traditional thread-bound transaction model. So in simple terms, if you're trying to find out whether you're going to use this stack or that stack, and you're trying to do it from the bottom up, start with the data stores. Can you select reactive data store drivers? That's a strong indication to go this way. Or arguing the other way, are you working with a traditional enterprise database with JDBC or JPA as your primary interaction API? Forget about that stack, right? Stay on the servlet model. That stack is really made for blocking API calls to process a request, right? Then traditional long-running resource transactions stay on that stack, right? There are many reasons to stay on a modern-day, highly efficient servlet stack arrangement. There's really nothing wrong with that. But if you have a reactive data store driver, if you're building a microservice architecture with a high degree of interaction between those services, and you are able to choose a reactive HTTP client library for this, then, and only then, that model starts to shine. That's why we're building this. Don't try to artificially use it, basically. Use it the way it's intended to be used, in combination with reactive drivers and reactive client libraries.
So why to use Java at all?
Why would you do this in Java at all?
Hey, why don't you use it like Node.js?
That's
Something like that.
an excellent point, but that's exactly where, well, basically where the story starts. We assume that you want to do it in Java. We want to enable you to be able to do this in Java, fundamentally in a Node.js style, right? Vertex is trying to do the same thing, kind of bringing a Node.js style model onto the JVM. We are trying to bring a more Spring-minded, more Spring-style model, more enterprise-oriented model maybe onto the JVM for doing the same kind of processing stacks. So we start with the assumption that you want to do it on the JVM, and typically, but not necessarily with Java the language. So to anticipate maybe a related question, doesn't this, or in particular this one here, cry out for Kotlin support? I don't actually have it as a sample here, but yes, it does. We have Kotlin extensions for the router functions DSL, so you can do the same thing with the Kotlin function model as well, which is even a tad nicer than this here. It's also made to be used with functionally designed languages on the JVM. Java 8 as the reference point, but Kotlin kind of as an equally first-class citizen. Couple of further things that I haven't been mentioning yet, or that I haven't been as clear about as I should have been. I was comparing those to like RxJava observable and RxJava single. You can literally use RxJava observable or RxJava 2 flowable and single completable here. Just declare it in your controller signatures. In the annotation-based model, we adapt to what you declare. So the only thing we want from you is a Reactive Streams publisher or something that we can adapt to a Reactive Streams publisher. And we have an adapter registry in place that, of course, naturally handles the reactor types, Flux and Mono. We have out-of-the-box adapters for the RxJava 1 and RxJava 2 types, but it's an extensible model, so even other libraries could be integrated, but I wouldn't recommend that. Use Reactor or RxJava in the end. This is also made to be used with existing code that you're delegating to. If you have the Couchbase driver, the existing one, which is RxJava 1 based, well, you might have repositories that return RxJava observables. Just pass them straight through, or do a couple of transformations and pass them through. So whatever you have that is Reactive Streams capable can be passed to the Webflux framework and is naturally understood by the framework. you don't have to use Reactor in your application classes. In particular, if what you're delegating to is RxJava based, I would actually recommend staying on RxJava and coding against the RxJava API. Another thing worth mentioning here is that the APIs between Reactor and RxJava 2 are very closely aligned. So the RxJava team and the Reactor team are kind of friends with each other. The amount of time spent on discussing the design between the two is quite an important part of the story. The signatures, the operators, like the whole then signatures, the flat map signatures, all the operators on the Flux and monotypes are almost identical to the operators on the RxJava 2 flowable type. So if you have a composition chain like here, you could almost replace like mono with single or flux with flowable, and the code would still compile because the structure of the operators is equivalent. Not necessarily all the callback APIs, but if you express them with lambdas or method references, you don't see the callback APIs. So if they are structurally compatible, the code still compiles. This is, of course, very intentional. They have been collaborating very closely to agree not on a common API type, that's a much harder job, but at least on common operators, common operator naming and common operator structures and common operator semantics. That's already quite some nice value. And the RxJava 2 project lead, David Carnock, even actively recommends reactors. So to quote him, right, if you're building a server-based application on Java 8, then David says use Reactor. The RxJava 2 project lead says use Reactor. Why would he say that, right? Well, RxJava lives under certain constraints. RxJava 2 was trying to be as backwards compatible as possible with RxJava 1. RxJava 1 isn't old, but the 3 years in its lifetime, in its production lifetime, it already accumulated some history, some legacy, you could argue, right? There's some things it cannot get out of. RxJava has a strong user base on Android, so it's Java 6 based. RxJava 2 is still Java 6 based. Doesn't make any assumptions about Java 8 APIs. It works nicely with lambdas and method references, but it doesn't use Java 8 API types. Whereas Reactor is Java 8 based from the start, Reactor 3. So it uses the Java util function types wherever possible, Java util optional wherever possible, right? It's a naturally Java 8 based API arrangement. So Reactor has kind of the benefit of late birth, right? Now that it arrived at a time when Java 8 was already established and reactive streams the APIs were already established. And of course, it's targeted towards a more specific space. And it doesn't have to be compatible with an earlier version of itself, like in RxJava. So in RxJava 2, they did a fine job, given their history and given their constraints. But they could only take it so far. Reactor is kind of RxJava 2, but from scratch, server-oriented Java 8 baseline, and like half the size. Of course, so it's also in terms of the size of the library, there's also quite a difference. Anyway, but it's essentially your choice. If there is existing RxJava code or existing RxJava know-how, existing RxJava preference, you're completely free to use it in the annotation-based model. So that's a benefit of the annotation-based model. We can reflectively adapt to your signatures. Whereas, of course, in the callback-based model, the interface type says, I want a mono of server response. So you have to return the Reactor monotype. You can adapt an RxJava 2 single. So if you had a single here, if the repository returned, or a flowable, if it returned an RxJava type to you, you can adapt it rather easily. Some signatures we even opened up to the degree where you don't have to adapt. You can pass any reactive streams publisher into the body method. So even if this was an RxJava type, we still understand that's a reactive streams publisher for the body. But you're going to have some Reactor imports in your code, right? Because ultimately the uppermost processing pipeline has to be a reactor type in this model. So that's our general story for this reactor versus RxJava, the whole API debate. We're doing the best we can to enable the use of RxJava 1 or 2. Actually, we prefer 2, but 1 is just more common out there. There's a lot of code, quite a few drivers that are RxJava 1 based, so that's why we're even bothering with both generations of RxJava. Yeah, that was all I meant to add here. And that's basically all I meant to say about the reactive story in general.